Friction. What is friction? We all have experienced that situation when walking on the floor normally, if you step on water, you slip and fall down. We attribute this problem to friction or lack thereof in this situation. So, what is frictional force? Friction is a force acting between two surfaces sliding over each other or trying to slide, always acting in the opposite direction of applied force. So, when you have two surfaces in contact and you apply some force to move the object such that it slides over the surface or tries to slide, then frictional force will be generated in the opposite direction. Whenever there is relative motion between objects, then frictional force slows down the sliding object. Such a frictional force is called kinetic force of friction. If even after application of force there is no relative motion between the objects, then this frictional force is called as static force of friction. Frictional force is directly proportional to the normal reaction. Removing the proportionality, we get F equals to mu n, where mu is the coefficient of friction. Value of mu changes for different surfaces in contact. Therefore, magnitude of kinetic friction will be equals to mu k n, where mu k is the coefficient of kinetic friction, whereas magnitude of static friction will be less than equal to mu Sn, where mu s is the coefficient of static friction. Now, let us have a look at a flow chart to understand how to recognize the type of friction. So, there is friction. We ask ourselves the question, is there relative motion at the point of contact? If the answer is yes, then it is kinetic friction, opposite to the direction of relative motion at the point of contact, and its value will be equals to mu k n. If there is no relative motion, then this is static friction, opposite to the direction of impending relative motion at the point of contact. It is a self-adjusting force. As long as you apply force, there will be static friction. Once you remove the force, static friction will go back to 0. Hence, its value ranges from 0 to mu s n. Now, we shall have a look at some examples and how this flowchart will be applied to drawing a free body diagram. First example, force is applied, mass does not move. Since mass does not move, we have static friction acting towards the left side opposite to the applied force. Then we label all the other forces. Mg acting vertically downwards, N acting vertically upwards. We choose the x and y axis. Therefore, along x axis, applied force will be equals to static friction, that will be equals to mu s n, and along y axis, N will be equals to mg. Similarly, if we have a situation where under the effect of applied force, M moves, in that case we have kinetic friction acting in the opposite direction, resisting this relative motion. Labeling other forces, mg acting vertically downwards, n acting vertically upwards, acceleration in the direction of applied force, and choosing our axis x and y. Therefore, along y-axis n will be equals to mg, whereas along x-axis f will be equals to mu n, that can also be written as equals to mu mg. Next example. A block of mass m is kept on a slope having inclination theta, but the friction is such that m does not move. In this case, static friction is resisting the motion. Labeling other forces: mg acting vertically downwards, its components mg cos theta, mg sin theta, and normal reaction acting perpendicular at the point of contact, choosing the axis x and y. Therefore, along x-axis we have static friction equals to mg sin theta, and along y-axis n minus mg cos theta will be equals to 0. Next example. Similar arrangement, but m slides down. In this case, kinetic friction will try to resist this sliding motion. Labeling everything as mg, components cos theta, sin theta, and normal reaction n, choosing the axis x and y, and acceleration down the slope. Therefore, along y-axis n will be equals to mg cos theta, and along x-axis f will be equals to mu n equals to mu mg cos theta. You can also find me on Facebook. If you have any questions, don't forget to subscribe.